Video problem 90, still with acids and bases, this time acid-base titration. A student conducts a titration reaction between 10 milliliters of 0.15 molar HCl and 0.25 molar sodium hydroxide. First question, determine the pH when I've added 5 milliliters of sodium hydroxide. Well, this is actually just a titration, a stoichiometry problem, is all it is. So what we're doing is we're taking HCl and we are reacting that with sodium hydroxide. And what we want to know is, do I have HCl left over, or do I have sodium hydroxide left over? And whichever one is left over, I want to know how much is actually left over. Right? Now, this is a neutralization reaction, so I'm going to form a salt, in this case sodium chloride, and a water. Okay. Now it's a 1-to-1 reaction. That makes it pretty easy. So what I'm going to do is I'm going to figure out how many moles I start out with. I'm going to figure out how many moles I use, and I'm going to figure out how many moles I end with. So what I like to say is I'm just going to SU it. Now the starting moles is going to be the molarity times the milliliters for both of these. Okay, so for the HCl it's going to be 10 times 0.15, which is 1.5. Now that's millimoles. And then for the sodium hydroxide, it's going to be 0.25 times 5, which is 1.25. And again, that's millimoles as well. So let's talk about millimoles real quick, make sure everybody's on the same page. What I'm doing is I'm taking molarity times milliliters, okay, which is really moles divided by liters, because that's molarity, and then milliliters is milliliters. So liters cancels out, but milli doesn't, so that's how I end up with millimoles. Right. Now this is the limiting reactant problem. I have 1.25 millimoles of sodium hydroxide, 1.5 millimoles of hydrochloric acid, so which one will run out first? Well, it's a 1-to-1 reaction, so that means I'm going to run out of the sodium hydroxide first. So I'm going to use 1.25 millimoles. So that means I have no sodium hydroxide left. I have only hydrochloric acid left. Right. So now I can calculate pH. Oops. Because pH is equal to the negative log concentration of the hydrogen ion. This is a strong acid, so it breaks up completely. But I don't have concentration, right? So I need to divide by the volume. The volume is 10 milliliters plus 5 milliliters, because I used 10 milliliters of acid and I added 5 milliliters of base. So I'm going to take that 0.25 divided by 15, which is going to give me 0.0167, which is going to be my concentration of hydrogen ion. Let me talk about this real quick right up here. So what I'm saying is HCl breaks up completely, one-way arrow. Okay, so it breaks up into the hydrogen ion, the chloride ion. So if this is 0.0167, this is 0.0167. So there's my pH. So 1.7, 1.8, because I should only have one sig fig. pH is equal to 1.8. Alright? Alright, so that's 5 milliliters. Let's add 20 milliliters of sodium hydroxide. So here I'm going to write out the reaction again. HCl plus NaOH yields NaCl plus water. So the HCl, I start out with still it's just 10 milliliters of that 0.15 molar. So I start out with 1.5 millimoles. For the sodium hydroxide now, it's 20 times 0.25. So I start out with 5 millimoles of sodium So how much am I going to use? I'm going to use 1.5 millimoles here. I'm going to use 1.5 millimoles here. So I'm going to end with no acid and 3.5 millimoles of base. So now I'm not going to calculate pH, I'm going to calculate pOH. And again, I have to divide by 10 plus 20 because that's my total volume. 10 milliliters from the acid, 20 milliliters from the base. So I get 0.1167. That's my concentration of hydroxide. So my pOH is 0.933. My pH is 14 minus that value, which is 13.067. Okay? Now I'm going to change this one because this problem, C, ends up being a lot like this problem up here. Okay? So let's see. Let's change it a little bit. Let's say that instead of 37.5, let's just say 7.5. I think that'll be fine. You know what? 7.5 doesn't work, so instead, let's change it to 3.5. Okay? Yeah. Alright, so I'm still starting out with the same amount. I've got 10 milliliters of that acid, so that means I'm starting out with 1.5 millimoles of the acid. Okay, so I'm going to take that 3.5 and multiply by 0.25, and that'll give me 0.875 millimoles of the base. Right. Now, I'm going to use 0.875 millimoles. So I'm going to end up with no sodium hydroxide this time. And then I'm going to take 1.5 minus 8.75, 0.875, sorry. And I'm going to get 0.625. Okay, I need the concentration of that, so I'm going to divide by 13.5 milliliters, so the milli cancels out. So I get 0.625 divided by 13.5, and I get a value of 0.0463 for my concentration of hydrogen ion. And again, that's because it's a strong acid, so the pH is going to be the negative log of that value. You get a value of 1.33. Alright. We're actually not going to do D just because we've already done enough examples. I think you got the idea.